For today's lesson, we'll be finishing up section 8.2, where we're writing linear equations. And we're going to add the last piece to our work, and we're going to take those equations and our table of values, and then we're going to plot points and draw a line on our coordinate grid. So in our previous lesson, this was one of the examples we did with the length of a rectangular picture frame is 5 inches longer than its width. And so we wrote our equation of L equals W plus 5. We created our table of values where if W is 1, L is 6, if W is 2, L is 7, and so on. So now we're going to add our coordinate grid to the picture here, and we're going to take what we have in our table of values, we're going to plot points, and then at the end we should be able to draw a line. So when we look at our table of values, whichever value is on top, those are going to be the values that you put on your x-axis. And if you remember, our x-axis is our horizontal axis. And then our second row, that's going to be our y-coordinate. So essentially what we have in our table of values is we have a number of ordered pairs. So our first ordered pair is 1, 6, followed by 2, 7, 3, 8, 4, 9, and then finally our last ordered pair is 5, 10. So when we plot our points, we look at that first order pair, and that first order pair is 1, 6. So we start our origin, we go to the right 1, and then up 6. And we plot our point there. And then our next order pair is 2, 7. So we go to the right 2 and up 7. Plot our point there. And then our third order pair is 3, 8. So we go to the right 3 and up 8. And we plot our third ordered pair. When plotting points, you must plot at least 3. You can do all of them if you so choose, but you need to have at least 3. And the reason we do 3 is that any 2 lines are going to be on the same, or any 2 points are going to be on the same line. So that third one will tell you whether or not they're all on the same line. In this case, all 3 of those points are on the same line. Our line must hit the x-axis, y-axis, or origin. And based on the position of this line, we're going to hit the y-axis. So we're going to come out from the y-axis. We're going to go through those 3 points. And then the last piece we need is we need to put an arrow on the end. So here's another example from our previous lesson with our gallons of paint and our equation of V equals 5C. And we now have our table of values. When C is 1, V is 5. When it's 2, it's 10, 3, 15, 4, 20, and 5, 25. So now when we look at our coordinate plane, if we leave it as is, we are not going to be able to fit 3 points on there. Okay? So we have to make an adjustment. Nothing says that you have to go up by ones. If you want to change the interval, that's perfectly fine. You can do so. And what you just need to do is you need to make sure that you are labeling. So let's say on this one that we decide that on our y-axis, instead of going up by 1, that we want to go up by 5. So in order to let me know that you're going up by 5, you must label your y-axis. And at the bare minimum, what you need to do is label every 5th one. So we label where it's supposed to be at 25 and at 50. Okay, but as long as you're giving me some sort of indication that you're not going up by 1, that you're going up by 5. Okay, so again, we plot our points. Our first order pair is 1, 5. Well, in this situation, we would go to the right 1, and then we go up 1, because when we go up 1, we're actually going up by 5. So then for our second order pair, we go to the right 2, and then up 2, because those 2 that we went up represent 5, 10. And then 3, 15. We plot there because every time we go up, we're going up by 5. And there's 3 5s that give me 15. Now, since I didn't make any changes to the x-axis, I don't need to label it. Kind of the default setting, if you will, is that you're going up by 1s. So again, our line, we have our 3 points, which we need. And then remember, it has to hit the x-axis, y-axis, or origin. In this case, we're going to hit the origin. You go through and then again, put the arrow on the end. So this was another equation that we had from our previous lesson. The width of a rectangular tank is 2 meters less than its length. So we want Q in terms of P. And if you remember, our equation was Q equals P minus 2. So when P was 1, when P was 3, Q was 1. Once 4 will be 2, 5 will be 3, 7 will be 5, and 8 will be 6. So we have our coordinate plane, and our first ordered pair was 3, 1. Our next ordered pair was 4, 2. Our next ordered pair was 5, 3. Again, we have to plot at least 3 points. Make sure that they're all on the same line, which they are. This one's going to hit our x-axis. We come out, again, put the arrow on the end. Excuse me. All right, so we're going to use the data in the table to plot points on a coordinate plane. Connect the points with a line, then write an equation to show the relationship between the variables. So if we look at our table of values here, our top, which is our x coordinate, 1, 2, 3, 4, 5, 6, we can use our coordinate plane as is, or our x-axis as is, but our y, our first value is 50. So we've got to make some changes here. And maybe you decide to go up by 50. So 50, 100, 150, 250 is right here. 3, 354, 450, 500 would be there. Okay. Or maybe you decided you wanted your graph to look a little bit different. Maybe instead of going up by 50s, you go up by 25, which is perfectly fine. What you have to do is just make sure you label. So if you went by 25s, your labels would look a little bit different, which means your graph is going to look a little bit different, and that's okay. So let's say you went up by 50s. Well, to plot 150, you go to the right 1 and up 1, because you're going up by 50. For 2, 100, you go to the right 2 and up 2, because you're going up by 50, and then go 3 and 3 to get to 150, and you draw your line. Let's say you went up by 25. So if you go up by 25, you're going to go to the right 1 and up 2. 2, 100, you go to the right 2 and up 4. 3, 150 would be to the right 3 and up 6. But still, you're going to have that line. And both of these answers would be correct based on how you're setting up your x and your y axis. Now, in all these examples, we did not make any changes to our x-axis, but you might have to in some of the work you do. So you can make your changes to the x-axis in the same way that you make changes to your y-axis. You might have to make changes to both the x and the y-axis, and that's perfectly fine. Your x and y-axis do not have to have the same interval, as we've shown in these examples. On all of our x-axis, we've gone up by 1s, but in our y-axis, we've gone up by 50, 25, 5s. Okay, so they do not have to be the same. And then the second part here is we have to write an equation to show the relationship between the variables. Well, if you remember from our previous lesson, the variable on the bottom, that's your dependent variable, which makes the top one your independent variable. And you get from 1 from 1 to 50, you have two options. You can either add 49 to 1 to get to 50, or you can multiply 1 by 50 to get 50. Well, only one of those is going to continue through. So we go to our next column. If we add 49 to 2, we get 51. If we take 2 times 50, we do get 100, which is what we're looking for. So D equals 50 times T is our equation. And that's all for today's lesson. As always, I hope this helps.